So I back to MC Mahira, please.
Thank you so much for Dr. Supriyanto and also Professor Masahiro Takei for the interesting subject. As a token of our appreciation, we will also send a certificate to your email. Once again, we would like to invite Dr. Agi Widyo Triatmo. The time is yours.
Thank you, Mani, and welcome, Professor Sini.
Yeah.
How are you? Nice to see you again. So I and Professor Siming are supposed to meet in Yogyakarta in 2020, but the pandemic has already occurred at that time. So we met in ICM Masar 2020 in online. So I hope that we can meet face to face in later time, Professor Siming.
Yeah, maybe.
Okay, I will be the chair of this session. My name is Agi Widyo Triatmo from ITB, and this session will be divided into presentation and for 30 minutes or 35 minutes, and then question and answer 10 until 15 minutes, and so we have the total time of 45 minutes. Before we start, let me read Professor Ming's CV. Professor Siming from School of Mechanical and Production Engineering in TU Singapore. So he is the associate professor in the Center of Professional and Continuing Education in Nanyang Technological University, Singapore. Professor Siming received a Bachelor Engineering degree in Control and Automation Engineering from East China Institute of Textile Technology, now under the name of Donghua University, Shanghai, China. He also got the prestigious overseas scholarship of Chinese government. So he has completed the postgraduate studies and doctoral research works, and has received the master degree from the University of Valencia. So I cannot mention it. So Valenciennes, France. Correct me if I'm wrong, in 1986, and as well as the PhD degree from the University of Rennes, France in 1989. So he has worked as a research assistant at IRISA in Ria Rennes, expert engineer at INRIA Sofia Antipolis, and now he's a lecturer, senior lecturer, and associate professor at Nanyang Technological University, and he also a fellow of Singapore MIT Alliance, or SMA, affiliated with the Innovation Manufacturing Systems and Technology program. He also had become guest professors in many universities and as a general chairs for many international conferences. In terms of scientific research, he has published several books, over 30 research papers in scientific journals, more than 100 papers in proceedings of international conferences. Now he will deliver the keynote presentation entitled "The New Foundation of Artificial Intelligence." So without further ado, please welcome Professor Siming. Professor, the time is yours.
Okay, thank you very much, OG, for the invitation. So I'm happy to share this research funding with the audience. So could you see I try to share my screen. Okay. Could you see my slide?
Yes, Professor.
Okay, so
Yes. So you can full screen. Yeah.
okay, now it's full screen.
Yeah.
Okay.
Yeah. Okay.
So I will take this opportunity to share with the audience about the state of the art in artificial intelligence, because recently this has become very hot research area. Okay, but actually, if you look at the history, we have initiated the third wave of AI in almost 10 years ago. Then 2 years ago, DARPA recognized we have entered this third wave of AI, etc. This is why recently it become very hot topics. Okay, so first of all, I will give the audience a short introduction about the nature of a third wave of AI. Then I will share with you about these 6 aspects of AI in which we could develop a very interesting application. And some of this area still have some remaining challenge. Therefore, and this could be the area for future collaboration, etc. Okay, so let's begin with the third wave of AI. And I believe every one of you heard of this Deep Blue project and AlphaGo. So Deep Blue project is a very old one, and dated 1996. And this project was founded by IBM. Okay, so it's a quite a famous project, and the outcome is also quite interesting because the program has beat the world champion. Okay, in 1996. So therefore, we must think about the conclusion that we can draw from Deep Blue project. Okay. Then recently, every one of you may have heard of AlphaGo project, because in the public, in the media, there's a lot of publicity about the AlphaGo. So similarly, we could also think about the conclusion that we can draw from this result. Okay, so therefore I just repeat, what is the nature of AI in the past 60 years, because if you look at the history of AI was formulated in the year 56 of the last century, so roughly about the 60 or 70 years of history. So you may agree with this definition of AI. Okay, so basically it refers to computer-aided human intelligence. Okay, but for public expectation, and every one of us hope to see that the future machine could have their own intelligence. Okay, then the question will be, is it possible for us to achieve this goal? Then I believe the answer is yes. Then the starting point should begin with this new outlook among the relationship among the body, brain, and the mind. So we must explicitly separate body from the brain and the brain from the mind. Okay, so here I just highlight the key function of the body. Body is for us or for machine to take action or to undertake a reaction. Then brain is for us or for machine to support memory and to undertake a computation. It is only the mind which will do 2 impressive tasks. One is cognition, another is recognition. Okay, therefore the key question is how to develop a machine mind. So that should be the key question. Then we need to look for solution, because in the early day of AI, a lot of effort has been put into developing computer-aided human intelligence. Okay, our focus is not really on the development of machines self-mind. Okay, so therefore we need to look for the new direction. So then starting from year 2003, because in year 2003, I have published a textbook on robotics, the fundamental of robotics, in which I specifically want to write the chapter about the robot intelligence, because I thought that the AI is quite advanced topics, so there's no need for me to contribute. But in the same year, 2003, if you look at the library, at the same year, the UC Berkeley professor published a textbook with the title of A New Approach to Artificial Intelligence. And he claimed that this textbook has been widely used in the whole world by over 100 universities. So I also bought this book. I just read the 10 pages of this book. Then I realized this is the area we need a lot of advance, because in the past 40 years, we just do computer-aided human intelligence. It's not really machine intelligence, okay? So this is why I spent almost 6 years from 2003 until 2009 to formulate this blueprint, okay? So we believe language should be the enabling tool for us to venture into intelligence. So language should not be an application domain of AI. Instead, should be the enabling tool for AI, because through the use of a language, we can create conceptual world. Okay, the conceptual world basically is our knowledge base or knowledge house. So knowledge is basically describes the property and the constraint of the physical world. Then you look at the university and the research institution. We have a lot of discipline in social science and the natural science with the mission of discovering or inventing knowledge in terms of property and the constraint. Therefore, we advance human intelligence, okay? So then this makes us to understand the nature of a human intelligence. Of course, we can develop a computer program to program a human way of thinking, reasoning, etc. Therefore, we have this computer-aided intelligence. Then you see at the beginning what I mentioned about the Deep Blue project and the AlphaGo project. All these are the result of a computer-aided human intelligence. Then for the public, our expectation is a machine intelligence. Then what will be the pillar for us to achieve machines' self-intelligence? The answer will be these 4 key pillars. But so far, we are quite in advance in terms of knowledge application, knowledge computation. We are weak in these 2 pillars. For example, knowledge representation, and is still considered as one of the major issues. But actually, we know the answer. The best way to represent knowledge is what? Is a human language. Therefore, the key issue here is to let machine to master human language. Okay, so this is one weak area. Second weak area is knowledge perception. And in AI, you may heard this term, symbol grounding. Okay, the weakness is not in terms of sensor measurement for the acquisition of a physical quantity. The weakness lies in the transformation from a physical quantity to conceptual quantity, which is named as a symbol grounding. Okay, so and our work contribution is make a breakthrough here and make a breakthrough here. So therefore, then we can tell to the public that we have discovered this new foundation, okay, which enable us to achieve this goal of making machine to have self-intelligence. Therefore, we extend the history of AI. So there's a new history, but the history of AI is very interesting. It's upside down. So you see, the first generation of AI aimed at a very high level is inference, reasoning, etc. But without the mastering of a human language by machine, all this is not achievable. Okay, So then people say, this is not the foundation of AI. Then in year 2000, because I'm also involved with this group of people between 1992 and 2000. Then these people say, it's not inference reasoning. This is just a behavior of the smart mind. But maybe we should focus on learning and the development. Today, you may heard of a lot of the past word like deep learning. Okay, then still venture into this direction. But actually, this is not the foundation. For example, you can let the car to learn for many, many years. The car can never fly. You can have an animal like a dog, a cat, to live with you for 10 years. But your dog, your cat can never speak your language, even when the dog, cat stay with you for more than 10 years. All right? So it should be the blueprint of the mind, and especially the ability to master human language. So that should be the true foundation of AI. So me as a third generation in 2017, DARPA, this is the Ministry of Defense in USA, also recognized we have entered the third wave of AI. So you see, so that is a recent history of AI. Then I spent almost 8 years to consolidate our research results together and carefully to assemble all the key points, and managed to get this book, and which was published in February of this year. So really, and this book has 11 chapters, and the most important chapter are in the beginning. Basically, the focus is to highlight the foundation and provide a very solid foundation for the third wave of AI. So therefore, now we have two definitions for AI. We can still keep the old definition because we can still develop computer-aided human intelligence, because we can find some useful application. But our intention should focus on this new definition. That means how to achieve a machine's self-intelligence with two impressive capability. The first one is to transform visual signal into the cognitive state of knowing the meaning behind visual signal. That is a cognitive vision. The second one is to transform auditory signal or audio signal or speech signal into the cognitive state of knowing the meaning behind all this voice and auditory signal. So these are the two pillars of new AI. Okay, so now we have two versions of definition for AI, which target at the two different levels of AI. Okay, then with these two definitions in hand, then we have this opportunity to advance new application, at least in these 6 areas. And these 6 areas basically cover these 5 keywords: perception and planning, action, and service to human being, and also let machine to have their own creativity. So last one is also advocated by us, design-centric intelligence. And the Singapore government also recognized this pillar as one important application, and which is supported by Singapore government with the funding. Okay, design-centric application. Now I'm going quickly through these 6 key areas for AI to demonstrate its full power and highlight a little bit the exciting application. Then for vision, this is a very old domain of application for AI, because for vision research, it has almost the same history like AI. And for myself, I did my master PhD in this area of vision. And recently, I also ventured into speech, etc., and link these two together. And the role of vision, basically for human being, is to transform visual signal into the cognitive state of knowing the meaning inside the visual signal. Okay, therefore, to achieve this scenario, input is image. So we see we can do image acquisition. Then output is the knowledge, is the meaning inside our mind. So all this knowledge can be organized, okay, into a network of database. We call it as a neural net. Okay, so you may heard of the image lab and the mind, etc. So this is advocated by us, neural net. So we have the meaning-centric network, etc. Okay. Then for industrial application, we can name this typical one, for example, 3D model acquisition, object recognition. So these are two important tasks of visual intelligence for industrial application. But the challenge are in these two areas, because for us, we can do photo interpretation. That means with the photo and without the 3D information, we are able to recover 3D information, the depth, etc. And also we can do real time and the scene understanding. Okay, so that is very impressive behavior. Then for 3D model acquisition and to transform an image into physical model, today there's no barrier, so no obstacle, so we can easily achieve this. So this is the result that we have done, and this has received a competition award, and okay, from Silicon Graphics, is a US company. So this is an award-winning result. So we do the passive scanning with the two image, then and use the scanning principle to obtain three-dimensional information. And this is done by other team. It's about the 3D model acquisition from a sequence image view from a different angle. So due to time constraint, I just quickly pass through. Okay, so this is a recent result. Then we move on, and for this one, this is set up also by us many years ago. So this is quite conventional. It's not the issue. If we use a laser projector to help to do this acquisition, you can see we can obtain very accurate data. And this is a video show you the setup of how.
First step is adjusting the camera so it's perfectly level and aligning with the center of the platform.
Due to time constraint, I just quickly go through. So that means you can have a rotating table and the laser projector. Then just use a single camera. Then okay, so you can get the very accurate data for this. Okay, so we move on. Then besides that, we can there's a requirement from the industrial for inspection of the quality of the product, quality of the printing, etc. And for transportation in future, so we may have the street camera or the camera mounted on board of the vehicle. Okay, then I move on because time is limited. Then in the highway, so this is what we want to achieve. Okay, so the vehicle has a self-intelligence, then he know the driving environment and the read the meaning of the signboard, etc. Okay, I move on. And this should be the breakthrough that we can achieve. That means have a similar human capability to interpret the photo, take a photo as an input, then output a three-dimensional impression of which correspond to the scene seen by the image. All right. So then this is one more application. Okay, in a city environment, the vehicle itself eventually may have a little bit of self-visual intelligence. Okay. I just quickly go through. Now, okay, move on to the speech-centric intelligence. This is also the second major pillar of AI, because for us, we can transform audio signal all the way to cognitive state of knowing the meaning inside the audio signal. Then for machine, we want the future machine to have a similar capability for intelligence. And therefore, for example, let the future machine can hear, can read the document, basically get the text, then from the text to extract the meaning and store the meaning into the neural net. Okay, and the impressive application should be one-to-many translation or conversational dialogue. But these two applications are still remaining challenge in AI. But for this one, it should be quite straightforward for us to achieve. Okay, so this is a scenario of machine translation. So then I skipped the video because to save time, and because the photo is good enough. Then in future, what we want to achieve is this conversational dialogue. The person can upload this video, then send the email to his friend. But eventually, we can let the machine or robot to describe the scenario seen by the robot, then send the email to tell his friend in Singapore. So basically, this is a video about the robot to play the football, okay, or something like that. All right. So, and okay, this video is below after us. So this is what even DARPA want to achieve in future.
I'm gonna hold the other end. Now what I want you to do is look at me. Look up at me. I want you to move that way. Get a little bit of a bend in the rod. Now look back at your rod. Look back at this rod right here. Try and get that straight so it's not too bent. And then come towards me a little bit. This kind good. A little bit. Stop. Okay. Now put a bend in it. Put a bend in it like that. Okay. Good. Now go back to straight. Make it straight. Very good. Now put a bend in it the other way. Okay. Now straighten it out again.
Okay. We move on. So basically, this is a co-worker. Okay, let the robot to work together with a human being. And in industrial, we have a lot of application like voice-based inquiry, and then have this the human-robot interaction. This is what we have done. Okay, based on the language communication capability. And this is more than 11 years ago what we have done here. And okay, now we move on to see what will be the planning-centric intelligence and application. So this is very much related to manufacturing, automation, and the robotics in particular. And what we want to achieve is to let the robot to automatically plan the motion which are related to the performance of the task. Okay, so therefore, so it means we let the robot to have the innate capability to plan what should be the internal process of a robot, machine, etc., which maximize the outcome and minimize the use of resources. Okay, so this is one area of research, but actually there are a lot of previous research result in this area. But today we are able to achieve a higher level of intelligence in this domain, and let robot to automatically plan, okay, its own motion. So these are the equation, and this video, then we can plan the robot arm to do and automate the manipulation, grasping, and eventually for this kinds of behavior, automatically open the cap of a cup, then pull the drink into another cup. So you see, so this is combining the behavior, okay, between motion planning of the finger and the motion planning of the arm. Okay, so we move on. And for locomotion, obviously, we also have achieved impressive result 10 years ago. So I just show you a little bit of video. Okay, so walking, jumping, and pushing, okay, etc. is another issue. Okay, today, so we have a very impressive result in this domain. Okay, then we move on to see how about the application of AI in control domain. So then we may have control-centric intelligence, and the focus is to link the perception planning together And instead of relying on human being to plan the desired output, then we can let machine to determine what should be the desired output. Okay, so today we can also achieve this level of intelligence and in terms of let's say vision guided manipulation. And here today is we can achieve easily the operation and for grasping and also for hand-eye coordination. So this is what we have done 12 years ago. So you see today robot has the full capability to do hand-eye coordination. So I just quickly pass through this video. So that means this is fully autonomous behavior hand-eye coordination. So 12 years ago the robot can do it. Then vision guided locomotion, and this also is 20 years ago what we have done for for the vision guided locomotion. So you will see this is a demonstration in NTU, okay, almost 20 years ago, okay, with two passive camera. Then this is in future, but in Singapore we are building the world's largest unmanned polar. Okay, so you see, I hope you can see. So you have a lot of unmanned guided AGV, like the vision guided AGV. So everything is being autonomously performed, okay, etc. Okay, so these are the example for locomotion. Then for voice activated control, and the typical application is for vehicle. That means eventually through the wireless connection, we can use our voice to control the vehicle. So let's turn on the engine and turn on the air conditioner. This is just a scenario, okay? Then before we enter our vehicle or something like that, turn on the internal light, on the engine, on the air conditioner, etc. All right. So then we continue.
Sorry, Professor. You have 5 minutes left.
Okay. I just quickly cover the last 2 points. Okay. Then for data-centric application, then this is the big domain. Every one of you may have heard of a big data, but for big data, we need the machine AI to help us, because for human being, we are not able to digest a report, digest a book in very short period of time. Then we can let the machine to digest all this report. Let's say we have an information generator, a lot of information generator. Then synthesize all this information, play this information in the form of a video. Then a group of people just watch the video in a few seconds. Then we understand the meaning. Then collectively, we make a human decision. So this is a typical scenario. Then in this case, we need to know how to organize the meaning, okay, inside the database, etc. So we have developed this framework of a meaning-centric network. Then, and besides military application, then in the smart city, smart building, hospital, school, factory, you can find a lot of application scenario which depends on the meaning-centric database. So I just quickly go through. And the school, hospital, environment, smart school, okay, and the education and the factory. So smart factory and the smart factory, etc. So lastly is about the design. So you look at the industry, you will see design is a part of manufacturing activities. So from idea to the design, fabrication, and the prototyping, and the marketing, etc. And then you look at the design activity from human being. We can take a text as an input, image as an input, just as an input. All this data or information come from your customer. Then we consolidate all this. Then we come out the design of mechanic system, control system, software system, etc. And then in future, we can let the machine to undertake all this activity, because the machine, AI will enable machine to understand text, understand image, understand the gesture, etc. Okay, so therefore we can design product, design factory, social system, and the public service system by machine themselves. Okay, so here I just show you the intermediate result about the product design, and okay, we have these two factory design, and then educational system design, and social or public service system design, etc. Okay, And with advance of AI, eventually we may think about our education is a better way to educate our student with the knowledge about the new AI. But due to time constraint, I'm not going to play the video. So this is a very interesting discussion, and people start to think about a new way to organize school. All right.
Tragedy.
Okay. So then I give some time for Q&A. Thank you for your attention. Okay. I hope at least you gain some insight about the current state of the art in AI. Thank you very much for your attention.
Thank you very much, Professor Siming, and please give him a big applause for the great presentation. And then I would like to collect some questions from the audience. If there is any, you can raise your hand or type at the chat. While we wait, I have a question, Professor Siming.
Yeah.
So we know that the current AI used many of our neural networks like the CNN or RNN and others.
Yeah.
So we know that the accuracy of those algorithms are only 90% or something like that right now. So what do you think if the AI at the current situation have the 90 or 95% accuracy is used for the critical mission, for instance, like for in the sense of the safety of health and also the finance.
Yeah.
So can we embrace the use of AI for that critical mission?
Okay. Okay. So this is a very good question because you touch on another critical debate about the neural network. And because I have no time to talk about our research finding in this area, because we already published somewhere, but we did not want to engage into this kinds of a debate. So currently, people use neural network as a mathematical tool to process the data, to get information. This is why they come out of this issue of accuracy, just now you mentioned. So actually, we do not believe neural network should be served as a mathematical tool to do data processing. Should be reversed, because we must ask this question. Okay, how come a human brain is in the structure of a network, neural network, and our brain can undertake two impressive activity. One is control the skill for the sport, gymnastics, etc. One is for the learning of knowledge. So we should ask this question. Our answer is what? Neural network structure is the best architecture to implement solution which are not neural network, to implement the solution for skill control and for knowledge learning. So we have example. For example, for the skill learning, for those of you, if you know the control theory, let's say we have a state equation. If you expand the state equation, actually you implement it is a neural network. And the state space equation allow us to model all the behavior of all the systems in physical world. So that is evidence of implementing state space equation in the form of a neural network. And the second evidence is in my presentation. You see this meaning-centric network or NeuNet. So actually that is a neural network for representation of a knowledge, but not for the acquisition processing of a knowledge. So for human being, because we have a very accurate information. For example, we drive a car, our behavior is robust. Okay, normal situation. Okay, we never commit in normal situation mistake if we pay attention. So that answer your question. So we do not believe neural network is an information processing tool, but rather than implementation of skill control, knowledge acquisition. This is like in one of the slides, I say we must have a new outlook at the body, brain, and the mind. Separate them. Neural network basically answer this question. what should be the best architecture for brain, for machine brain? You see, body, brain, mind. So neural network should be associated with brain, but not associated with mind. What is lacking is the mind. Okay, what should be the blueprint of the mind? So that answer your question. Because for our brain, basically is a neural network. That is hardware aspect. It is the best architecture for hardware. Okay.
So it is interesting because so do you mean that we need to combine with the physical phenomena and also the model of physics that we already know for a long time ago, and then we combine with the skill of learning to optimize and to get the best parameters for instance, controls.
Yeah, correct. So your question is very, very good. So then the answer in you see the blueprint, the new blueprint of AI at the bottom, you see physical world through the language. Then we have a conceptual world. So it's that part we must make a breakthrough. So currently we achieve that. So this is written in our new book. This is why we share this result, because in the past almost 50 years we stuck there. We stuck with this problem called simple grounding, because today with so many sensors, all the available mathematics, we are able to transform a signal into physical quantity like temperature, pressure, and the physical model of any dynamic system. But what is lacking is how to transform physical quantity into conceptual quantity. It's like this car moving very fast. This is red color, for example. For us, they say, this is red color, this is a circle. We never in our brain say, this is an equation like x squared plus y squared equal to 10 squared. But that is a physical quantity, John. X squared plus y squared equal to 10 squared. But for us, it's a conceptual quantity is a circle with a radian 10. That should be the output. So it's that part missing, simple grounding. Then we consolidate the past year's result. Then we discover actually solution is there. Okay, so then we put it, then explicitly tell people, okay, how to do this simple grounding from a physical quantity to reach the conceptual quantity. Once we achieve that transformation, then the rest, then we open a lot of possibility already. Then another issue is about this machine translation. Let's say one-to-many translation. Current method is lookup table. Okay, then through the semantic network lookup table. But for us, it's not like this. We transform conceptual meaning back to physical meaning. It's like when you hear a sentence, let's say a tiger eat rabbit, for example. Then in your mind, you have an image. That means from a conceptual world, we can go back to the physical world. Then from the physical world, once we understand, then we can translate it into any other language. So you see, then we achieve a breakthrough in one-to-many machine translation. So it is the last layer of this, and we are the only one to explicitly spell out that we must separate conceptual world and the physical world. Because for old AI, they mix these two things together. They never separate this. We must make a clear separation. Then you will see we can go back and forth, okay, from a physical world to conceptual world back to the physical world. Then that open avenue for new application. Yeah.
Okay, thank you, Professor Siming. It is very interesting. So, very short question: can we buy your book and get the signature from you directly?
Yeah. You visit my homepage, because first slide you know my homepage link. Then go to publication. There's a link. Yeah.
Okay.
It's everywhere.
Thank you. So our time is limited, so I will pass time to MC.
Okay.
Ms. Mahira.
Yeah, thank you very much. I hope if you are interested in, then this can generate some further discussion, maybe offline through email. Okay. Yeah.
Yeah. Okay.
Okay. Thank you very much for your attention, and thank you very much for your invitation. And hope to see you in future. Yeah.
Please give big applause to Professor Siming.
Okay, thank you. Thank you very much. Okay, bye-bye.
Bye-bye, Professor. Thank you.
Yeah.